Data mining, similarity and distance. An analysis of dissimilarity measures distance calculation and approximation method from the provided questions. Choosing your measure. Computing dissimilarity for different data types. Dissimilarity by attribute type. Part 1. Nominal attribute. Example department, elective chosen, method, simple matching, mismatch count, logic. We check if the values are the same or different. The dissimilarity is the ratio of mismatches to the total number of attributes. Formula is given below. B. Asymmetric binary attributes. Example, attended workshop, method, Jacquard distance, logic, we ignore 0 to 0 matches. For example, two students not attending as they don't imply similarity. We focus on the presence of a feature. Formula is given. Dissimilarity by attribute type. Numeric attribute. Example, CGPA, attendance, method, Minkowski distance, logic, calculate the distance between 2 points in multi-dimensional space, requires normalization if scales differs. For example, CGPA 0 to 10 versus attendance 0 to 100. Common forms, Manhattan distance, Euclidean distance. D. Term frequency vectors. Example, keywords in open textbook. Feedback. Method, cosine dissimilarity. Logic measures the angle between two vectors, not their magnitude. It's ideal for sparse data like text as it focuses on the proportion of term used. Formula is given. Calculating distance. A worked example with common metrics. A worked example. Given vectors I 22, 1, 42, 10 and j 20, 0, 36 and 8. The differences are 2, 1, 6, 2. Euclidean h is equals to 2. The straight line gives the answer 6.708. The Manhattan gives the answer 11. Minkowski gives the answer 6.153 and Supremum gives us some answer. Part 3. Median approximation of big data. Random sampling. Method. Compute the exact median of a small random sample of the data. Trade-off. Extremely fast but less accurate. Accuracy improves with sample size. Quantile digest. Method use a probabilistic data structure like T-digest or Q-digest to store a compressed summary. Trade-off. Very good accuracy with controlled error bounds. Low memory usage and fast reservoir sampling. Methods for streaming data maintain a fixed size statistically representative sample of the stream. Trade-off balance memories and accuracy for the data that can't be stored entirely. Case study student feedback applying similarity measures to real data. Question 8. Ranking by similarity. Comparing query vector x 1.4 and 1.6 against the student profile. Here we have a table with attributes student vector, Euclidean, Manhattan rank, supremum, cosine sim. Observation. Different measures produces different rankings. S1 is the closest for most distance metrics, but S3 is the most similar by cosine angle proportion. Question at the effect of normalization. What is normalization? We divide each vector by its magnitude to create a unit vector. This process isolates the vector direction from its magnitude. It's like asking what is the proportion of a1 to a2 regardless of the total values. New Euclidean distance on unit vectors are s1 versus x is 0.00405, s3 versus x is 0.00780, s4 versus x is 0.0440, s2 versus x is 0.092, s5 versus x is 0.26. Key takeaways are: measure choice is critical. The type of data, nominal, numeric, text, dictates the correct dissimilarity measure. Metrics tell different stories. Euclidean distance is sensitive to outliers, while Manhattan is more robust. Supremum finds the single greatest deviation. Normalization changes the question. Normalization data isolate the direction from magnitude. Use it when the shape of the data matters more than the scale. Approximation is key for big data. For massive datasets, approximation technique trade a small amount of accuracy for huge gains in speed and efficiency. Thank you guys for watching. If you have any questions, please comment down below.